All right, so the goal with this is to show you guys kind of how to use RobotStudio to virtualize robots. Now with that, I am going to go fast. This is going to be all recorded, so you can bounce back and forth wherever you need to, but I want to make sure everyone has kind of an introduction. So first thing we're going to do is open up RobotStudio. If it's not installed on the computer, we want to aim for the newest version generally. It is almost completely backwards compatible back to like 10 to 15 years ago. So the newest version of RobotStudio is the way to go. Now, once we're in RobotStudio, I'm going to go ahead and set a few settings just for you guys to know what's going on and make sure your RobotStudio works properly. So I'm going to point out a few things here. Licensing, this is where you set your license. So we're going to go to Activation Wizard, and you are going to connect to a network server. So we'll hit Next, and this is where you'll type in the server that all of our licenses are loaded on. Once you finish this, it will ask you to restart RobotStudio. Mine was already typed in. It's not going to make me restart. A few other things I want to show you in that same area is after I've specified that server license, I can check out a commuter license. That means that if I cannot connect to the local network, it means that I can still use RobotStudio and all of the licenses that come with it for a set number of days. If you're going out to other customer sites, this is what you're going to want to use a lot of times. Then again, a lot of what we do in robot programming will not actually require you to use a RobotStudio license. So as we go, I'll kind of show you what needs a license and what doesn't. Now, the last thing I want to show you guys here, this is nothing more than a quality of life. We'll explain why it's very nice later. But if you go to Behavior under Graphics, you can modify what each of the buttons does. By default, middle click will actually cause you to zoom in and out, which is very opposite of CATIA. So what you'll do is, let me go ahead and set it back to the default and hit apply. So you'll see the middle click is set to zoom. That is very annoying because that is not how CATIA works. So we're going to go ahead and disable that. And then we're going to go down to pan, and we can select the second combo or second text block right here. And then middle click off to the side, and it will go ahead and add that middle, and we'll hit add. And now pan works with a middle click, which just makes moving around in RobotStudio much more similar to the CATIA we're used to. Hit apply, and you're good to go there. Now, I'm going to go ahead and hop in and show you guys how to make a virtual station. So by a virtual station, I mean we are going to create a virtual robot that you can do all of your programming on, all of your testing on. It will work exactly like a real robot for pretty much all of our tests. With that, we're going to go ahead and head over to New. It'll say, let's go ahead and create a station. Oh, they've changed this a little on me, so this is new. We're going to create a new project, and we are going to go ahead and include a robot and a virtual controller. That way, as we make the project, it will go ahead and actually install a robot. Now, there's two options. Generally, we will be creating from a backup because we have a customer that already has a robot, or you're working with MRAM or something similar. So I'm going to go to our backup folder, and I'm going to select a random robot from the hundreds of backups I've taken. Let's go with somebody's 4600. So once you select this, it will go ahead and tell you the robotware that you're using. The robotware is the operating system that the robot runs on. Now, if this is your first time opening and installing RobotStudio, you will not have any robotwares available. All you have to do to get one is head to the add-ins page. Give it a second. This does require you to be online. It is loading their entire catalog, so it does take some time. And then depending on what robot you're working on, if it is one of the brand new models that uses the OmniCore controller, which looks something like this image, then you'll want to install one of these robotwares, preferably the one that matches your robot. Or if you're working with the older style controller, which is the IRC5, you'll be able to install these. So with this, we'll just go ahead and click on one of them and hit add. And this doesn't require IT to give you permission to do it. It is relatively painless. So we'll see this green progress bar. We're going to go ahead and continue without that since I already had some loaded. But as we go through this, you'll go ahead and see that finish installing. I'm going to go back to File, go back to New. We're going to create from a backup. It tells me what the backup version was, what my current version is, and then it gives me some options. So I can restore the backup as it creates the robot. This means that it will save all of the code currently on the robot and put it on the virtual robot I'm making right now. If you're trying to make a brand new system, then that's not what you're going to want to do. And it finished installing, so it is kicking me out. There we go. So I'm not going to have it restore a backup, and I'm just going to come out with a plain Jane robot. So this is going to be RobotStudio lesson project. And then if you want to have some fun, feel free to name your robot. Generally speaking, it just puts the serial number there or some generic thing there. So we'll hit create, and this is where we'll have to give it a bit of time. It's finding the model, it's moving all the files over and creating the file structure for your new project. And here we can see it finished installing RobotWare 13.04. With each version of RobotWare, they do tend to add some useful features, a couple more functions, something. Generally, we don't have to upgrade our robots that often, so I wouldn't mark it as something to be concerned about. So in this case, it gave me a couple of options with the models. Some of our robots have different variants, as in they just have more cables mounted on the side, or they're a different color, or there's small changes to them. And this is where we get to select what kind it is. This is, I believe, the robot loaded over in Deloitte with the injection molding cell. So it uses 4600 and it's white. So I'm going to go with the one that looks like it's white, and we'll hit OK. And it will bring in that robot, and we'll have a nice, pretty model of it. So it is just the model of the robot. If you are trying to bring geometry in and show a full virtualization, you can import geometry, but I'm not going to hop into that quite yet. First, what I want to show you guys is the fact that this virtual robot is the exact same as a real robot for all intents and purposes. Okay, so this means that I have access to regular programming. I have access to everything. So please, if you guys are doing just random testing on the robots, go ahead and use a virtual controller. It works really well. All right, so we're going to go back over to that home tab and walk through a few things that we have sitting in here. So if you have something that is already part of the ABB library, or the robot comes with from ABB, a lot of those models are already included. So if we need to add other robots, other positioners, it is in here. Or we can add in other models that ABB has. So if you want to show the controller, the weld tips, and even some basic tools that ABB has pre-made for you, so you can do a proof of concept, we can do that. So we're going to start with just a little weld robot head, and we're going to tell it to attach to the end effector of the robot. The way we can attach it is there's two ways that we'll typically do it. We can either just grab the end effector by clicking on the drop-down box or the tab on this left-hand side and go up to the robot, and it will say, you are attaching it. Do you want to update the position? Update the position means it's just going to snap it into place. I'm going to go ahead and hit yes, and now it has snapped it into place. Now on that, if we don't want to click and drag and do connections like that, we can right-click on it and hit attach over here and then find out what we want to attach it to. I want to attach it to the robot, so I'm going to select the robot and hit yes. Now, whenever you attach a actually declared tool inside RobotStudio, what it will do is it will create that tool data for you. Tool data refers to the TCP and the payload and a few other things of a robot. And it is asking that, do you want to replace it? You attached it, so I created the tool. You detached it and attached it again. So do you want to overwrite that existing tool? I'm going to go ahead and hit yes. From there, I'm going to hop over to the Paths and Targets tab. Please note I am in the Home tab. As you start moving throughout tabs, you'll notice some of your sub-tabs start disappearing. So in the Home tab is where you'll do a lot of your virtual programming. And I am going to go ahead and create a quick model. So we do none of our modeling in RobotStudio because it is absolutely disgusting. But if you want to show a very quick and ugly block, you can do that with a few of these commands over here. So I'm going to create just a quick block. It's going to have its origin located at 0, 0, 0, and I'm going to make it 4 inches big, not a meter, and hit create. So now I've got this part hidden inside that tool or inside the robot. I'm going to go ahead and use that move command to bring it over. And now I have a nice pretty block. So the reason I did that is so that I can show you how we might use RobotStudio for programming and doing it a little faster. So I'm going to go back to that home tab and then paths and targets. Now, under the controller I'm currently working with, inside the current task I'm working with, we can see that tool data that got added. So just to reiterate, tool data stands for the TCP, and the TCP of the robot is kind of the active part of the robot that it is working to position. If I tell the robot to go to an XYZ coordinate, it is that active TCP. So this little tip right here that it will try to position at my XYZ coordinate. The reason that's really nice is if I switch out this tool with a different weld gun that the TCP has changed or the tip has changed on, I can tell it to use a different active tool, and it will just correct all of my points to match that. So we're going to go ahead and create just a quick little procedure here, or a path. So I'm going to right click on paths and procedures. You can also add a path up here, but I find it more convenient to just right click and hit create path. And we're going to use path 10. You can rename the paths to whatever you want, but this is a good starting point. So from here, we're going to create a few waypoints. So first, we're going to create a move instruction. Now, there are lots of ways robots can move. They can move, the most common are move abs J, move L, and move J. So we can look at what each one of those does here in just a moment, but the way it selects what kind of motion it's going to be is in this bottom row right here. There are the move type, the move speed, the zone data, the tool, and the work object. So we're going to go ahead and change this to a move abs J. Move abs J's are really good for your first motion because they are always the same, they are always consistent, and you know exactly where the robot is going, although you may not always know where the tip of the tool is going. So I'm going to go ahead and create or insert a move instruction. Hit create, and there we go. So this move instruction, we're going to go ahead and hit modify position, and that will set it to where the robot currently is. By default, it just gave it some joint values. If we want to teach the instruction where I'm going to go ahead and create another motion under this home tab for a move J. The biggest difference is going to be inside the rapid code. In terms of simulation, they will behave the exact same. So I'm going to teach another instruction at some random position. Let's go over here. So teach instruction, it'll add it to the end, and then I'm going to tell it to synchronize to the controller. Now we're going to go back. We're going to go back to rapid where it'll show the actual controller values, and we'll see each line of code. I really don't like it whenever my stuff ends up crunched like that, so let me change that. So move abs J's, if we look at what it's moving to, we can right click on the target value and hit go to definition, and it'll highlight it for me. It is of type joint target, and joint targets tell you exactly where each joint will go. So each joint has its own degree. Joint 1 is going to 6.45 degrees, joint 2, 30 degrees, and so on. If you have external axes are things like tracks, turntables, stuff like that. Those values will be stored in here. And once again, it will be joints and it will be angles. Versus Rob targets, while we're looking at it, let's go ahead and look at what a movement consists of. So the movement always consists of the position it's going to, whether that's a joint value or a Cartesian coordinate, doesn't really matter. How fast it's allowed to move. So that speed is based off of the TCP of the robot. Move J's and move abs J's will tend to get you to positions faster, but the fact that they kind of have a sweeping motion makes them hard to predict, and it means that you can collide with stuff a lot easier. So move L's have the benefit of not running into stuff. Next, we have zone values. So whenever you are moving between points on the robot, we're going to go back to that home tab and take a nice look down at some of these movements. You'll see that the corners are relatively rounded as it comes around, and that is because of that zone value. So a zone value will cause it to round the path between two positions to make sure it doesn't have to come to a sudden stop and then change directions. So just to show you kind of the difference, if we change this to a find value, find just means it's going to stop at each of these positions right on. And we run the simulation again. The corner got a lot sharper. It comes to a sharp point. So if your robot looks like it's moving very jaggedly, it tends to be because your zone values aren't big enough. Now, zone values do have the problem of it does actually change the position the robot went to. So if you're trying to be accurate when picking something and you have a zone value on there, it may cause it to run into it rather than picking it. So that is something to watch out for. Next, we have the tool data. And the tool data, as I said, is the TCP, or the part of the robot that it is trying to position. That actually has no effect on the position it goes to in a move abs J, but it does determine how fast the robot can move in a move abs J. Now, you may be wondering how that doesn't make sense. It's not monitoring that. The reason it does watch for that, and that does matter in a movement, is if I have a stick sticking off the end of the robot that's 10 feet long, and joint 6 is swinging as fast as possible, that means it could be moving 10, 15 meters a second because it's got so much length on it. And that's going to be a problem from a safety perspective a lot of times, or just the momentum it'll build up. So it is making sure that wherever the tip of the robot is never goes faster than XYZ speed. And then last but not least, we have our work objects. So work objects are coordinate systems, and we'll dive into those next here in a lot more detail. So I went back to the Home tab, and we're going to start playing with some of these work objects right here. I'm going to go ahead and create a new work object, and I want it to be on this work object one will be okay. It will round the corners. I don't like that. So I'm going to come into each one of these motions, and I'm actually going to do this the quick way. I can click on it and then shift click to the end and get it to get rid of all of my zone values. So I want it to be Z0. Now, the difference between Z0 and fine is fine actually comes to a true stop for a split second. If you're watching the robot, it's almost impossible to know. But with a Z0, it doesn't come to a true stop, and it will blend about the last 0.1 millimeters. And at that point, it's good enough for what we need. And the last thing I want to do is I want to make sure my rotation isn't absolutely crazy. So I'm going to view my robot at a few of these targets. That looks like a really weird position for the robot to go to. That one looks pretty weird. I like that one. So I'm going to use 50, and I can copy its orientation from the target. So I right-clicked on the movement, and I'm going to find what target it is based off of. I can then right-click on this target and hit copy position and orientation. So I'm going to do relative to the world, and then I can paste the same orientation to all of these, and I just want the orientation. So now they're all rotated the same way. Now, I told you guys that having a move abs J or even a move J is the best way to start a move. So first thing I'm going to do is change this move L to a move abs J, which means I can just double click on it and modify. Oh, not modify. Edit instruction, sorry. Instead of linear, we're going to go to joint. And this means that if I have my robot in such a way that it can't move in a linear line, so for reference, whenever I say can't move in a linear line, there is no way the robot could draw a straight line from here to here without going through itself. So a move abs J gets me away, or a move J or a move abs J will get me away from that issue. So I'm going to snap back to that first position. And then we are going to fix this yellow caution sign. So with a robot, I mentioned the configuration data. This configuration data is telling it that joint 1 should be at somewhere between 0 and negative 90 degrees. Joint 2 should be between something and something. Joint 3, so on and so forth. So we need to fix that on these motions right here because they currently can't be reached in its current configuration. Easiest way to do that is to right-click on the path, auto configuration, and just hit all move instructions. And you'll see it got rid of that. That's because it corrected the configuration. Sometimes it will fail to correct all the configurations, and that's typically because there's no way for it to get to point A to point B without traveling or without having to change the motion or spin in a circle or something weird. That just means that you need to. So I'm going to move that back in. So I'm going to go ahead and delete that whole path now, and I'm going to delete the path before that because why not? Now I've deleted these paths. Now, one thing that is a bit of a pet peeve of mine is it will leave the targets that were previously defined in here. That gets really annoying. You can right click on the robot and hit remove unused targets, and it will clean out the stuff you're not using. So, and then I still have TCP trace on, which is just leaving white lines on my screen and driving me nuts. So we're going to go back to TCP trace, and I am going to clear it, and I'm also going to disable it. That way it doesn't keep drawing lines on me. All right, so let's run through and do another auto path generation. So we'll hit drop down on path, auto path generation. I'm going to shift click again so it does the whole face. And then I will give it a approach of 100 and a depart of 100. If you need a lead in, you can also mess with the starting offset. So negative 100. Or let's go something you can actually see. So let's do negative 200. Oh, it won't let me, will it? No, it won't. So it won't let me offset any further along that line that it's starting on than the length of that line. So this isn't anything we use too often unless you're trying to do a really big lead in for welding to start. 3D printing would be somewhere you see a lead in because you need to start extruding before you get into location, but it's not one we play with all too often. Same thing goes for the end offset. If I do a 30 millimeter offset and 30 millimeter offset, you'll see that it doesn't actually cross that point anymore because I've added an offset. I'm going to go back to 0 because I like it to hit all 4 corners and it looks much prettier that way. Sweet. Okay, we'll hit create. I'm going to close that window because it's in my way. Going back to path 10, I'm going to make that first movement a move J again. So edit instruction, a joint move. We'll hit apply and close. I'm going to fix the rounding issue because that looks disgusting. This time I'll do something a little different with the zone. I'll do a 5 millimeter zone, and you'll see it rounds it, but just a little bit. That might be good enough for your weld, and it'll make the robot motion look significantly smoother. All right, so last thing we're going to do is find out which orientation I actually want the robot in terms of which rotation. So this first motion, I'd say maybe that's the perfect angle for welding, or maybe I need to update that angle. So I'm going to jump over to a few other things. First, we're going to jump back to the simulation tab, and I'm going to show this one area real quick. This is going to lead us into the controller and how to actually define I/O on the robot. So I'm going to go to station logic, and this area right here is where I can draw connections. I can say whenever the robot turns on this I/O, it does one of these things. So I mentioned robot I/O. I'm going to show you guys how to define I/O real quick. This is the same thing we'll do in a real robot and a virtual robot, and I'll mention a few of the tiny differences between the two, but it won't be anything significant. So under the controller tab, I'm going to go to configuration, and then I'm going to go to I/O system. As you guys get more familiar with robots, you'll learn a little bit about Ethernet IP and a few other communication protocols that is connected to the welder. This is where you'll select that. Right now, we haven't defined any, so it's not there. We'll play with that a little bit more here in a little bit. So the robot is going to have to turn on the welder. The next thing we're also going to need the robot to do is it doesn't need to start moving until the weld has actually started welding. That is going to be an input. That is the robot waiting for information back. So that's going to be digital input, welder, and then weld started. As I said, that'll be a digital input, and we'll hit OK. All right, so we have both I/O defined. anytime you make a change in the configuration tab on the robot, you'll most likely get a warning down here that says you changed the configuration, and the robot will not acknowledge this configuration change until you've restarted it. Although this is a virtual robot, the same rules apply. So you can use this restart option up in the top, and we'll let it restart. And this will apply those IO changes. Okay, so now those IOs are actually defined, and we can use them back in the simulation tab. While we're here, I'm going to go ahead and dive a little bit into this. You guys can blank out for now if you don't really want to learn about it, but Ethernet IP devices and how to define them and actually connect to them. All you have to do is come over to Ethernet IP device, right click and hit new Ethernet IP device. What kind of device is it? So ABB has some of their own devices that they've already made. They're typically already bolted inside the controller, or we order them separately and they're specifically from ABB. Those can show up right here, and you can say I'm connecting to the ABB local. And now, the reason I wanted to show you all of that is we're going to go back to simulation and go to station logic and say that when the robot, so out of all of its IO signals, DO start welder and DI weld started. Anytime I start the welder, it's instantly going to say the welder has been started. In the simulated world, we're going to generally go for the best case scenario and say that it's instantaneous. If you want to add a delay, that is an option, and we'll actually go ahead and do that here. So what I did to get that menu to pop up is I right-clicked, and I can go over to Signals and Properties, and I'm going to add a logic gate. This is a very visual way of programming, and it's exactly like what it sounds. It's a logic gate, and you get to decide what the logic gate does. It can be AND, which means that only whenever both signal A and B are true, will it send a 1, or one of the other, or one and or the other being on will result in a positive output. XOR means that if one or the other but not both is on. Not means it just inverts it. And then normally open. This is what you're going to use if you just want to add a, let's say, 1 second delay to the robot. I can say once the robot weld comes on, I'm going to treat that as an input to this logic gate. The output of this logic gate will go to DI welder started. Save my changes, that way I don't forget. Please save early and often, it's always a good idea. So I've created this little loop. Fair warning, there's very few ways to make this look pretty. It starts looking like a nightmare very fast, and I am sorry to say it will always look like a nightmare. It is visual, and it is not the best visual way of doing this. You can go into the individual signals and connections and try to set it up manually, but that can get a little exhausting to read through after a while as well. So I do not think there is a great way to do this either way. All right, but what I wanted to show you guys is I'm going to go back to view so I can see the pretty robot. Makes me much happier. And just as a refresher, and one thing I don't like is right now the robot doesn't have a floor, so it's floating in space and it looks really weird. That's because in my settings, I have show floor disabled. By default, the robot will go ahead and show a floor, and it'll show a grid. You can always create your own block or import a model that has a floor, though, and you don't have to worry about it. So in this path, I'm going to go ahead and show kind of the order of operations you normally do whenever you weld. So I'm going to go to my pounce position is what I'm going to call this move J. The next one is the right where I'm going to start welding. So after I get to the second move L, I need to add an action instruction. Action instructions are anything that don't result in the robot actually moving. I have a 100 millimeters a second with 6 motions that are about 100 millimeters long. I also have a 1 second delay on my weld starting and my weld stopping. That means first thoughts, the fastest this robot should be able to go is it should take 8 seconds. And that's assuming it has an instant acceleration. One thing interesting about robots is they have 2 program pointers. So that means as it's executing, it is actually looking ahead and seeing what it can do in the meantime to get ahead of itself. The problem with that is I don't want it to start my weld until I'm in the correct position. So That means we need to add something here that causes those program pointers to stop and line up for just a split second. That way it only starts the weld after I've gotten to position. So one problem here is that I made that change in the rapid part, but you will not see that change over here. This change, whenever you do synchronize, if you hit the drop down rather than just the top button, you can go backwards. I can synchronize to the station. This is called the station. I keep calling it the simulated robot, but we will synchronize to the station. I'm going to select path 10. Do I have a path 20? I don't have a path 20. We're going to get rid of that old path so it stops confusing me. So I synchronized to rapid or to the station, but it still doesn't show that wait Rob. That's just because that wait Rob doesn't actually exist in the simulated version. It only exists in rapid code. So another way we can ideally get the robot to stop before it continues is we'll go back to the home, and I'm going to change this motion and the motion right before I reset the welder. So anytime before I'm setting an IO, if I change those to a fine value, it should have the same effect as a wait Rob in pose. So we're going to synchronize this to rapid again, hit simulation, and hit play. And we'll see we get the same result. So a fine movement does have the same effect as a wait Rob in pose. It's just a little hard to visually see when someone has used a fine. And it also means you have to go through and specifically set the zone value before each time you set an IO. Sometimes it's just nicer to see you've added a wait Rob in position. Now, another option we have is we can't have the robot just wait for a set amount of time. So we're going to add a action instruction to path 10. It's going to go where I clicked earlier. We're going to say wait time, and then the amount of time. Let's do half a second. A lot of times we'll add these wait times so that there's time for the robot to get suction on something or for it to stop shaking. If we have really bad mounting for the robot, it will tend to shake as it gets to position. By adding a wait time, it's a lot more fun to play with it on your own.